Let's start. Let's go live. If you're ready in three, two, one. Hello, everyone. Good morning. Happy Sunday morning to you all. I'm so glad that we have today with us Professor Chinnasamy, who is a faculty at IIT Bombay. He so I was going through his resume. It's a very long resume with lots of achievements, but I'll make it brief and I'll let him take it forward from there. But to give a brief introduction, he along with his him being a professor at IIT Bombay, he is also director of RUDRA, Rural Data Research and Analysis Lab in IIT Bombay. While he is doing this, he's also a visiting professor in some other university. His projects are sponsored by government of India. Some of the projects has been sponsored 50 somewhere between 50,000 US dollars to one of the projects being sponsored 14 million US dollars. The name of the project is Free Open Source Software for Education and Engineering. His research paper, so his written, so his the total number of research papers publications that's been published are 35, which is a big deal, which is a very huge number. And I'm really glad that we have him today with us talking about how to utilize big data and AI for health monitoring and assessment for rural India. And for whoever is new here, this webinar is a part of COVID Gameathon, which is sponsored by the US Consulate of Hyderabad. Uh, the aim is to enable participants to develop games to fight COVID. So from the insights that we'll get from the professor, we'll understand that how we can use data, how we can use AI, and how we can use or integrate this learnings and this skill sets and this technicalities into the games that we are building to be able to fight COVID. So yeah, I'll let Professor take it from here. Whoever is on Zoom, feel free to put your questions in the Zoom chat. For whoever's on YouTube, feel free to put your questions in the YouTube chat, and we'll make sure that by the end of the webinar, we'll ask your questions to Professor and get them answered. Professor, please take it over.
Thank you. That was a very generous introduction. Let me share my screen and let me know if it shows up. While it's showing up, those who have questions, please raise your hand, or we can also take questions at the end. Is my screen visible?
Yeah, it is.
Just move this out. Okay. So good morning and good evening wherever people are, because again, this is US Embassy, so hopefully others are also watching. So my topic for today is big data and AI in health monitoring and assessment for rural India. I specifically put rural India because there is a lot of issues and concerns in rural India. Sometimes they are left behind. When the country, like there's a lot of advances in other aspects, rural are left behind. So this particular topic looks at focusedly for AI and ML for rural India. And so just a small introduction, I'm an assistant professor with Center for Technology Alternatives for Rural Areas, which is one of a very unique department in across IITs. So this center / department is only focuses on rural development. Okay, so that is a key, and that is one of the reasons I joined this department before I was in Singapore. So then I started my lab, which is called Rural Research Data Analysis Lab. So this is all in IIT Bombay. And I can once again, you guys find it interesting. So I'll go through a personal introduction. It is key to understand about data. So normally I don't do a personal introduction, but I do it here because I think it is key for our understanding about why data labs and why needs. Need for rural database, so we'll just cut across some data points and what data you could use for health and AI and ML. Understanding drivers from the data. What does the data tell you? Big data and AI in health. So we just completed successfully a case study and across India. So we'll go through that, and some learning curves from that could be used for your gameathon, because you want your game to be applied. And this talk, I hope, would sensitize on the data and sensitize on what is going to come out of your AI and ML. So that's one thing. And the aspect of this is for the organizers. There's a tremendous growth for this aspect in India, which is big data and AI. So keep pushing, and I'm so happy that you guys have so much chance to work on it. And a conclusion. So my personal introduction is I got a master's, double master's in physics, and then I did my PhD in hydrology in the US. So once I finished it, I came back to India to work on water projects, because India also has a lot of concerns on water quality, water quantity, etc. So I started my career as a hydrologist. But then when I came, I couldn't find a lot of data. So data access is pretty hard across Asia. It's not only in India, but also in the developed countries like Singapore, where I worked for the government. The data is really, really hard. So then what I found is I switched a little bit to remote sensing. Remote sensing is mostly for satellite data. And the term big data means data in high frequency and high volume. Okay, so when someone asks you what do you mean by big data, it is a data which comes and updates in a high frequency and in high volumes. So by default, your satellite images are, or satellite data is big data. It's one of the biggest data you can get, because every day around 10 petabytes of data comes in from all the satellites in the world, and that is actually free data. Okay, and you can ask and procure data. So if someone asks you what data you work on, how do you claim it as big data, you can always say satellite data. Satellite data is by default big data. Okay, so and it comes every 6 hours, every 3 hours, so we have sub daily levels, etc. So hydrological models I work on, and using remote sensing. And my research profile, I started as a research scientist with A3, which is an NGO in Bangalore. And then I moved to international water management, where I worked in countries India, Sri Lanka, and Nepal. And then I was as an NTU as a senior scientist. So all these places, and now I'm a visiting faculty in Oulu, Finland. But all these places, never I worked with data labs. This is why I want to show my personal introduction. There is no data lab. Okay, and most of the work I did across this is hydrology. It's not for a particular region. So when I came to IIT Bombay, where I am working focusedly on marginalized people or rural development, I found that the data was even worse compared to other places. So it is not like it was neglected, but the extra effort to consolidate that data was missing. So that is where I started RUDRA, Rural Data Research Analysis Lab. It is one of the first in the country to be housed in an academic institution, and also has access to a supercomputer. IIT Bombay has one of the most powerful supercomputers in India. And so we work and liaise with, our models are run on that computer. So there's a lot of things I'll show you why we need a supercomputer for AI and ML, and how you could do it on the cloud AI and ML. Okay. So rural issues are complex. So you need a holistic understanding. If I just want A plus B is equals to C, I just need two data, and that is not normally the real world problem. And right now you're working on a COVID for health, health, AI for health, big data for health. So when you want to talk about it, you want people to use it, which means the application side has to consider a lot of holistic variables, not only your medical variables, not only your data about medicine, hereditary, etc., etc. So same way in rural, it is very, very complex. If someone says, why does a farmer suicide? It is not just because he didn't get money for crops. There's multiple reasons. And only if you address all the reasons, you are going to apply your model there. Small understanding is, if we want to stay about rural water development, where do we start, where do we end? We just say that, is water enough for everyone? You start with that. Not only water for drinking, you have to have water for agriculture. So when you have the agricultural produce, you need that produce to be processed in a lab, or an industry. Do we have that much of water for the industry? And then the final thing is, do we have water for the environment? Otherwise, if the environment doesn't get the water, your land is not fertile enough. So all this combined, this is what we call holistic. Every key stakeholder is targeted and understood about water, and etc., etc. So all this, again, each one is now a big data. Okay, so if I just start with one aspect, it is only one data, a plus b equal to c, but here we have multiple. Already we have 4 parameters. So what has happened about data? Before I jump into the big data and AI health, a lot of caution is needed. A lot, I would say. If you want to become a successful data scientist, you need to understand the data, not be just a computer scientist. Why? Because, as I'm going to go show you a little bit of, you know, so there's a lot of issues in the data. So first, understand the data. Don't take the data and just use it as any other model. In computing terms, when I learned my first software, it was called GIGO, right? Garbage in, garbage out. So if you give garbage into a model, it will spit garbage out. The model does not know if it's garbage or not. Okay, it's not trained that well. So you can never, at least till date, you cannot like take out a human interface. But again, understand your data, and that's very, very important. And lots of literature is about data issues. Very, very key issues before you start with health is there's a lot of insufficient data, less spatial data, which means if you want to do a model for a district, look at if the data is available throughout the district. Okay, and temporal data is, do you have it in spurts of time or a regular time series, which means every month, every day, those kind, or just like once in a blue moon, once in a week you have data. So those things you have to be very, very careful about, because the timing of the data also has an influence. Is the data representative? Only some population of the data could be reflected on your data model. So make sure that it is representative. The density of data, is there enough density of points? If you're taking points of data, make sure it is density is enough. The last one, which is very, very important, and I would say powers the other thing, is what is the instrumentation? How do they collect the data, the methodology? Understand that. Because some, for example, if I'm measuring a table with a centimeter, my resolution of my scale is centimeters, I cannot put the values in millimeters, like 0.33 millimeters. No, I cannot. Why? Because the scale itself is in centimeters. So some people would do that by averaging and bringing down the numbers, which is totally wrong. So make sure you understand the instrument, what is the resolution of the instrument, and then stick to it. Okay. And this is what we did for South Asia. So South Asia, we were asked to, by the World Bank, we were asked to look at climate change, health, and impacts on water resources. I find a lot of connection between climate change, water, and health. Why? Because most of the big diseases because of climate change is spread by water. For example, after a flood, there is diarrhea, malaria, dengue, etc. And then this COVID has become another issue, right? You needed water to wash your hands. A lot of people were suffering already without water. What we could say is water is very important. And before we could jump into what is the status of these people, we found that before understanding the status, the key issue is data insufficiency. Okay? Again, I talked about this. There's a lot of insufficient spread, bias. Some data are biased towards particular thing, and grouping is representativeness. You can see in the India map, some data is grouped, and because of that, the groundwater vulnerability is there. Okay? Physical and technical issues are there, and sometimes the data is temporally not enough. Like just once in 4 months, data is collected for groundwater, and groundwater is related to diseases. Okay, like fluorosis, rickets, all these are related to groundwater. So water has a big role in your health. Representative data, as I said, are we taking data from the field or outside the field, from the field where fertilizers are applied and water is, etc. Okay. So the quality gaps are, it has issues in accuracy, integrity, is it structured and managed? All this, please make sure you address in your Gameathon. Consistency, bias, is there bias to the data, and validity. Okay, so the WHO standards, ISO standards, are these data valid? And outdated. Some people use too old data. We don't even know what instrumentation was used. So make sure you understand that, and uncertainty of the errors. Okay. So how it goes is you have a lot of time taken for data collection, and some people do not clean the data. So I would strongly recommend everyone who's working on these gameathons to look at some models, some pre-processing techniques to clean your data. Okay, because again, there's a lot of errors that can come by manual entry or remote sensing entry, algorithms. It just creeps in, and then there's something called propagation of errors. So make sure you understand these error points and then clean the data. And data gaps are there, don't just interpolate it. Look at the data, understand the data, and then fill the gaps. Most data you take and the models are empirical models. What do you mean empirical is? It has some correlation and relation. I could ring a bell with COVID predictions, right? Most of the predictions were empirical in nature, which means last 10 days, this is the, this was the number of cases. So next 10 days also, it will be like this. We train the data on the 10 days. Okay, when you train a data, you force a data to a particular model, then it becomes an empirical model. When you have a physical model, it actually takes into account what was the climate in the 10 days. For example, for COVID, people said, it increased during the winter season. It could increase. That's why the ACs were turned off and all those things, right? So did they find that as a variable in their model? And then in the summer they said it will come down. Did it come down? So those kind of things, please understand what kind of algorithm are you using. If it is an empirical, it is purely based on XY relationships, okay, which is how is the one data related to the other. If it is a physically based model, it's multilinear, multi-regression models where you have multiple variables to get one variable, and data gaps are big issues. And again, lots and lots of data is spread across these sustainable development goals. I won't get into this, but when you're working on it, please take all the other data which is also available. Okay, all these would help in your COVID mapathons. Poverty, because when you're poor, some people said poor people were more vulnerable, and hungry people because they had less nutrition food to fight the COVID. Because these kind of data is not put in the COVID predictions. If you could see, for Africa they put because it was generalized in Africans prediction models, but for Indians they didn't. Because some regions are really self-sufficient with food, whereas others the nutrition level might not be the same. So is it done? And gender inequality, they treated all the population as same. Is it correct? Access to clean water for COVID. You need water to clean your hands, drink water, clean, etc. Was that included in the models? And then all the other things, right? So make sure that you can collect these data to put into your physically based models. And the last one was good health and well-being. So the good health and well-being always requires water, but again, please try to see if there was some data that is related to your COVID mapathons. And again, this was the issue about data availability and stuff. A lot of targets are set for each country for sustainable development goals, and you could see that it is not being met as per the data collected. So my question is it not being met, or do we don't have data to prove that it is being met? So I think it's the latter mostly, because the data is not there. Okay, so for COVID, people were not ready to understand what data to collect. So that by that time, some time passed away, and valuable time was lost. Okay, so I've given us a short but very important introduction about what kind of data you could get for health indices and malnutrition and etc. etc. And how you should tie it up. Don't just focus on a model that predicts data by a training database. Okay, a training database is good. Yes, it can capture most of it, but understand that when you're dealing with health and health related aspects, human value is very, very important. Okay, and we would show this right now. I'll show you a couple of models in AI and ML that we did for India, across India, full of India. Okay, so where you can collect data, etc. So big data and AI in health is big and emerging. So I'm very happy that most of you are participating in these challenges. It starts from anywhere in the picture, as you see. It could be the entry that you come in and give the doctor. It could be the medicines that you buy. That data can get into the big data. It could be your diagnosis, your heart rate, pulse, ECG, scans, etc., etc. Your blood test reports from the biochemistry lab, your temperature, your nurse visits, and whatnot. Like, so where you are from, all these things, what kind of drugs were given to you to fight it. And then based on that, there's a lot of apps being built, right? You now have a doctor on call. You have apps that can do some diagnosis. Like, for example, the COVID app that the government of India has released. You can take a self questionnaire, and if the self questionnaire finds you vulnerable, it will give a signal to the nearest station, and you would have to go and check in yourself. Okay, it'll ask you to run at once. So, and it also shows you if the nearby people are having COVID, and how can you be careful about it. So be very sure how the data is there, and how it's based. And then we have a very big extensive data set. I would call kind of a big data is your NFHS data, National Family Health Survey data. It is collected very frequently, unlike the census, which comes in every 10 years. This is more frequent, 2 to 3 years they collect. It's a project between the US aid and the government of India. So US funds plus the government of India's funds are put into this very extensive data collected for health. Okay, primarily for health, and then you can do a lot of these visual data analysis. So this is ranking of districts of India by child health. Okay, so where the child health is good, where the child health is bad, etc. And just looking at it, okay, you don't have to be any scientist, or you could see that why is the central of India really red. Okay, why? And then you can look at it, and then maybe focus in more. Gujarat's Kutch region is really red. So this is what you could pick up from visualizing of data. So data is good to visualize, and then bring a good understanding. Okay, so, and nowadays you have these Google AIs. A lot of these people would have seen the talk given by the Google CEO on how a Google software can predict a disease from looking at the eye, and because of the historic visits. Okay, so just because every doctor, when you go and visit, they look at your eye, and then they say, okay, what is wrong? Show me your eye. And then most of the things are found in your eye, right? So why do you need a doctor? That was the question. And then they brought out the CEO, gave a good talk about this Google AI for health. If you have time, please look at that video. It's very interesting. So then we're on road to have these doctors that are based out of these AI and ML, or bots, chat bots and stuff. So while this is happening, it is also it is good for some reasons, but is also concerns. Every product has its own pros and cons. So please understand, is it good? If not, why? Okay. Those kind of things you should come up by understanding what data went in to make the model. All of these are based on data. Okay, it is not a robotics based on engineering. It is based on data. So the data, please understand, and go back to the questions where I showed you what are the issues in data and how that can influence your results. As a case study, let's look at your data that went into your COVID. And most of you would agree that most of the predictions, be it from the English regions or the Western regions like US, Canada, and etc., most of the models failed. By now, India should have seen a lot of concerns in COVID, and people predicted we would overtake everyone and go really sky rocket, and the country that predicted is going above us. So just look at where we are, and how it happened, and that is purely because of the data. Okay, the data that they used for the models and the algorithms they picked might have had some influence on the data, and that is where on the results, and that is where the normal situation was much different from the predicted situation. Okay, and this is a couple of graphs I would like to show, and there's a good study about it, a case study in model failure, COVID-19 daily deaths and ICU bed utilization predictions in New York State. And yeah, if you look at that predictions, you'd be like, if someone was a New York mayor, they would like really faint looking at the predictions, because there's no way they could have, fought that situation based on the predictions. But the predictions were wrong. So why were they wrong? How did they go wrong? Etc. Etc. is beautifully discussed in this paper. So please, I would request most of you to look at scientific journals. Do not look at COVID prediction models. Look at why they failed. Okay, because if they passed, if they did well, by now we could have easily contained it. We couldn't. It is just still going on, and now Maharashtra is seeing a second peak. So make sure you understand what kind of predictions went in and how they went in. AI and big data, all these models were used using AI or at least big data, okay, techniques. So AI and big data should be aimed at replacing domain expert, but to work together. What my point was here is most of these predictions, if you see, for example, John Hopkins model or the London School of Economics, most of it was built on mathematicians, statisticians, AI, computer scientists, etc., etc. Was there a role of a doctor? Was there a role of a stakeholder? Was the big question. Okay, some people did have it, some people didn't. So was that the change between the model predictions? That is very, very important according to me, because I work mostly on the applied side. So I take the model and go to the ground and check if the model is working. It's not just a model that you give to the government. You have to make sure you check the model. So when you want to divide your topic, data science subject domains is a very good, interesting thing. I always teach my students in IIT. So data science domain, there's a lot of, this is mostly the mathematicians, statisticians, your computer scientists, modelers, etc. Okay, they talk about structures, visualization, analysis, AI, ML, etc. comes there. Then you have your domain expert. Most of the time, the domain expert is missing. Okay, because you have the data, you can train the data from AI and ML. So why do I need a domain expert is the question. That is a very grave mistake, I would say. You cannot afford to do that mistake, especially when you have it. If you don't have, for example, I don't have data from the space. Can I do an AI and ML? Fine, you have no other way. But here you do have domain experts, you have doctors, you have pharmacists. Why don't you use them? So that is also good. So the domain, you have domain specific data and visualization models, the type of models they use. A doctor would not use the same models, and organization roles. And I'll show you clearly in an example I'm going to show in my RUDRA lab. So RUDRA was never supposed to be health and education monitoring for rural India. It was purely for water, because the issues in water is very big. So, but as I said, when we were doing water, we saw a very, very close relationship between the availability of water and diseases in rural India. So that is where I slowly, little bit flexibly took in health data. Why I'm using these terms is, then someone should not ask me, are you a doctor? Why are you doing rural health? Okay, so I am not a doctor, but there is I'm a hydrologist, but there is a very big correlation between water and waterborne diseases. So I attack only the waterborne diseases, okay, so which are spread using water. And we also have a doctor on the team for analysis. So Dr. Rupal Dalal is a professor at Sitara, my department, and she's a doctor. She's also a doctor. So we do can consult with these people for further investigations. So the topic I would like to quickly go through an example is potential of machine learning tools to predict childhood anemia. And again, anemia, there was a lot of correlation between COVID because of immunity and how your body could reflect the virus, etc. So it was done by Mr. Gaurav Dubey under the supervision of me at RUDRA. So Gaurav is now a passed out student. So I'm thanking him. I won't be reading all this, but what is important to understand is anemia is very, very big in India. Okay, anemia is the in non-technical terms, do you have enough good blood in your system? Okay, the blood levels. If you are low in anemia or anemic, then you'll have to be asked to get you a blood bottle into your body. So that's why you have blood donations and all this stuff, right? So insufficient hemoglobin content is what the medical term is. And for children between 6 and 59 months, there's a threshold, and a lot of Indian children sadly do not meet it. Okay, so the machine learning is becoming a popular tool to understand this research, and most popular term is classification. How do you classify anemia? Okay, the multiple levels of anemia. How do you classify it? Because once you classify it, then you can predict anemia. The aim of this study was to predict anemia in India. Okay. So we used not only one AI method, we used logistic regression, naive Bayes, decision tree, random forest, XGBoost, KNN, linear discriminant analysis, LDA. Why did we use this? Because every now and then, every 6 months to a year, new models come up. When I was learning, XGBoost was not there. It was only mostly random forest, decision tree, etc., etc. But then we also had XGBoost, and now it's just upgrading itself. So all these models are coming in, and we have to be prepared to understand and make the system flexible to incorporate it. And why this model compared to other models? Okay, because all of these are models which have bias towards the data, and so not all models can work everywhere. Only some models can work for anemia, some models can work for malnutrition, some models can work for gender specific issues, cancer. So be very careful what model you use. So the first was to start with data. People say a lot of data is missing, we don't have data. But again, as I said, your National Family Health Survey data, which is NFHS. Just Google NFHS, you'll find it. It is free open source data. Anyone can access it. Okay, anyone. So just go ahead and take the data, and it's very exhaustive data, around 200 columns, which means 200 variables that you could, more than 200 variables that you could use for your study. Any study, not only for anemia. You can, as I said, for cancer, for other things, you could use it. Is a health survey data. The method they use is health survey. Okay. So our aim was to look at anemia levels in 0 to 59 months of children. Okay? And for children, we got 24 lakhs, I think. Yeah, so 2 lakh 44, around 2 lakh 50,000 children data. And when we clean the data, when I said cleaning was very important, we cleaned the data, it fell almost half. Okay, so some data were lost because the data was bad. So this is where I clearly say that around 40% data was lost. So you clearly say, please look at the data, understand the data, so that you can clean the data before it goes into your models. So we're now coming back, this is just a basic visualization, no analysis at all. You could see that anemic versus non-anemic, and then different age groups. We segregated it into from 0 to 59 months, into 6 to 11 months, 12 to 23, 24 to 35, above 35 months, because each month would have its own weightage. For example, your 0 to 6 or 6 to 11 months, you have more breastfeeding, right? The child drinks the milk from the mother, which is highly nutritious, and it fights anemia. That is where you could see a very less anemic in the very young age. But then when you go up, your anemia level also goes up. Okay, so be very careful and understand why this happens. And more data could be easily collected from higher age groups. Then child anemia versus iron supplement intake. So those who took iron supplements, were they having less anemia? Those kind of analysis is just basic analysis. There's no AI and ML in it. Then we did some correlative analysis, looking at data. This is before you want to clean the data, okay, or after you clean the data, and before you want to choose a model. So child anemia versus wasting. Wasting is when you have the height versus your weight is not correct. Stunting is when you're short. Okay, when the child is short for an age, when you say like by 3 years you have to be X centimeters and you're not, then that's stunting. Okay, so that is an indicator of malnutrition, and malnutrition is tied to anemia. So all these we are trying to look at in one go. So the basic methodology in any of these AI and ML methods would be to look at first you take the data, clean the data, and make it less noisy, which means too much vibrations is not enough. So some people do averaging it out. Okay, so when you look at these COVID models, you would see the 7-line moving average. It ties beautifully closer to the predictions, whereas the actuals don't. So that is where an averaging technique would help. Okay, then data transformation is important. You normalize or discretize the data depending on the model, and you reduce the data because of redundancies and other issues. Okay, so that is, you take the initial data, and then first visualize it using histograms, box plot like graphs I've shown you. Then you know how to clean it. Then you start cleaning the data. Okay, and then you reduce the data to what is actually needed. You don't need all the variables, all the columns you don't need for your model. Okay, and that also depends on your domain expertise. Though you cannot neglect a data set because you feel it doesn't go well. A domain expert has to be there, right? So then you train the data, you split the data into training set and then your testing set. A training set is where you tell the AI model, this is how the data is and this is how the prediction is. Okay, so this is how you would predict. Now give me a prediction. So that is your training data, and then your testing data. Now the AI has given you an algorithm, A plus B is equals to C. Then you run the model and then you test it against your observed data. So that is the key data splitting feature. So of your data, you split the data into two. Then you build your models, different models, and then you do a model validation. There are multiple validation techniques, train and test holdout, k-fold, and then leave one cross validation. So to know if the model has done well. And then you evaluate the model. After you validate the model, you evaluate the model using indicators, R square, MSE, RMSE, adjusted R square. And then you classify the model based on their accuracy, sensitivity, specificity, and precision. So these are terms in models where you put weightage on the predictions. So you classify and then. So there is something called parameter tuning, which means you have some parameters, but they're not likely to be influencing your model unless you do some parameter tuning or hyperparameter tuning, which means the parameter or the variable has to be tuned or scaled up in remote sensing, we say, to be taken up by the model. Otherwise the model will neglect it. It's too small for the model to even accept it. So there is some parameter or hyperparameter tuning. Okay, so in this methodology, we did take the data for, and I think this is where it helps you in the COVID situation model. We took NFHS data, which is for the whole country at a block level. And then we did a model. As I showed you in the previous slide, we use the same methodology, data, and then at least 7 models we did in AI. And what we found is the model is, we did 4 different types of model. One was for the whole country, where 16 variables are taken. Out of 200 plus, we took only 16 variables. And the default hyperparameters were present in Python were used. We only used open source. Why did we only use open source? Is so that if some government agency wants to take it up, then they don't have to buy it. There's no cost for the company, but they just use open source tools. So we use open source tools to do these models. And only 16 variables were taken based on the domain expertise and also how much correlations were there. Okay. Then we did the second part. So the whole country model, we did some hyper tuning. So when we did some hyper tuning, as I said, some variables which were less pronounced at the first model became more pronounced. So now around 8 more variables were used. So it became 24. So from 16, we pushed the model to 24 variables to predict anemia. This is the model 2. The model 2X was asterisk was the model 2 asterisk model was using a country model for a district model. So if I do a COVID analysis for the entire India, is it acceptable for Kerala is the question. So that was what we tried to understand in model 2 asterisk. And model 3 was a particular district, just a particular district. We took the data and then did the same modeling procedure of model 1 and model 2, which means we neglected all the models. We started fresh by taking the district data, finding the 16 parameters, and then hypertuning them to get at the prediction of anemia. The input was 16 variables, as I said, age group 6 to 59 months, and our output was prediction of child anemia. So these were the 16 parameters. I don't want to go in. I think it's going to be shared so everyone can look at these variables. And what was the response as per the NFHS survey? As you can see, it's a survey. So not much quantification is there, but binary and different variables are there. Again, how do you get from 200 plus variables to 16? By using a domain expert. So we sat with the domain expert, we looked at all the variables and asked how each variable is tied to anemia. And then they gave the understanding how it is, like for example, male, female, size of the child at birth, etc., etc. These are the results, and in the results what we found was the LDA models performed best along with the logistic regression, which means for a very complex data set, the very normal logistic regression was enough. So this is where again some people overkill by saying I'm going to use AI and ML. Logistic regression was not an AI, but it could compete with other ML languages, machine learning languages, because of the value of the data. Okay, so and the problem in hand. So for that particular problem, normal regression was good along with the LDA. So XGBoost performed well as compared to random forest and decision tree, and KNN was the lowest metrics. So as I said, you analyze the model and then you analyze the results of the model using indicators, precision, accuracy, etc., etc. So that's what we did. And then we also cross-validated the model to show how the model is good. Okay, so as I said, LDA and linear logistic regression was the best ones. Okay. Then what we did is we took additional input variables, just not the 16. Then we looked at a lot of literature. This is again the domain knowledge. If you don't have domain knowledge, read papers. These are doctors writing papers in medical journals. So the example they said, low birth weight and low dietary diversity has shown anemic in children. And then Barnawal said drinking water, sanitation facilities, cooking fuel, and household smoking have the association with anemia. So no one would ever think it. My father is smoking. Why would a father is smoking? Why would the child get anemia? You know, they won't understand the logic. But there was. That's what the domain expert says, and this is how it works. So they would say how that smoke will get into the child and induce anemia is the medical terms, right? So then what happens is studies have shown that other studies have shown we have so caste also as a big factor in predicting anemia. So now we added more additional inputs. Okay, I said low birth weight. This is all based on the literature review and the domain expert. We reran the model. Now what has happened is your decision tree became much better accuracy, but XGBoost gives accuracy and highest accuracy and specificity. So if you look at the previous modeling exercise, only LDA and logistic regression was good. But now your XGBoost became higher, which means your AI ML driven models became much higher if you know the domain. Okay, so make sure you don't know the domain or use the domain expertise. Again, cross validation was done to look at the accuracy, and XGBoost was better. So now we went to the model 2 asterisk, which is using the Indian model. So what we had previously was for the entire India, we did the model. And then now we use the same model to analyze anemia or predict anemia at a district level. Okay, so we took random districts. Again, we used a random mod analyzer to just pick randomly districts. Good thing it picked a very good data, like one Mumbai where we had an urban, highly urbanized, highly populated region, and then Dalai and other regions where it's less populated, and then we have also rural, semi-rural, semi-urban, and then urban. That's how we pick the models based on random calculators. So first districts were selected randomly, and then if you look at the XGBoost model that did very well in the India state level, did not do well in the district level. Okay, The model is not able to identify non-anemic cases efficiently. Large-scale model failed when they are used to predict anemia in district level. This was the key message that we brought out. A large-scale model failed miserably when it was used in the district level. So in a lot of these AI/ML, they use this one-size-fits-all approach. For example, if it works here, it should work there. Just replace the data set, it should work. It doesn't. This is what the study had shown very clearly. Like the model which did very well at an India level did not do well at a downscale level. Okay, all the metrics were out. All the metrics were out except the logistic regression. So logistic regression was the better compared to others. Identification of important features. So after we did the model and we looked at the algorithms and how the weightages were placed for each parameter, XG models are used to identify top 5 important features. So it will give you weightage about each variable, right? So then it gave us which variables are important that we analyzed, and then again went back to the domain expert. So think carefully. Before we ran the model, we sat with the domain expert, understood the variables that had to go into the model. Then after we ran the model and got the results, we again took it to the domain expert to make sure that these features that have high weightage on the model is correct. Total gain is considered for selecting important features. And then what we found is per study region, we found for Dalai region, of the 24 features, we found child age is very important. Okay, so if the child has anemia very young, then it is more pronounced to be having anemia throughout. Women anemia, if women had anemia, then the child will also have anemia. Education of women was a very key factor. Caste, because as some papers introduced, a particular caste is more vulnerable to anemia. Why, etc., has made medical reasons, but because maybe their dietary patterns were similar, or they didn't have access to clean water and food, those kind of things. Household size, if the household size was too big, then the portion of food or nutrition that went in was low, those kind of analysis. So that was what for Dalai. And then we looked at Sonbandra. The number of features changed. Child age was there, caste was there, education of women was there, but women BMI was another big index. Okay, so another big feature that was very important for a different district was women body mass index. And then diet diversity. So you cannot have the same diet. That's where in Tamil Nadu you'd see that the an egg a day a meal, right? Like for the free meals given to school children, the introduction of egg has improved their nutrition status a lot. So a lot of studies have shown that, and a lot of other states are following it up, even in some states where eggs are not easily accessible. So eggs have become a very important source of protein, a very low cost protein for children. For Mumbai, it was different. Sanitation. You could see that sanitation is a big problem in Mumbai for this case, because sanitation is where if you're clean and enough water for cleaning and cleansing, then anemia won't happen, according to studies and according to this model. Okay. The other things were the same: child age, women anemia, diet diversity, education of women. So for Mayurbhanj, it was almost same except the female media exposure or education, and if they know what to feed. So that was a big factor in the model. And then child underweight status and stunting status. These are malnutrition statuses. So the discussion is, now we found that some key features are there. But if you look at government programs for fighting anemia, like Anemia Mukt Bharat under the Poshan Abhiyan, and other dashboards that they have, most of them have very specific to the anemic problem, which means like, okay, eat more iron supplements, and then have more other type of food, etc., which is also caught in the model. What was not caught is the education of the women, the caste vulnerabilities, the sanitation was not discussed in the government programs. So what is the use of this model is the question, right? So by these models and by these game mapathons and gameathons that you do, you should identify features or add to the government's model. So the government's model already exists for fighting anemia. And what we found out is, yes, whatever you're using is correct, but add these features also. So they had like features of iron tablets, supplements, and then women anemia, women body weight checking, all these things they already have. We added more dietary importance, dietary diversification, caste, education of the women, media exposure, those things we added. And you could see a lot of ads coming up on anemia and etc., eggs, etc., on national TV. Okay, so need to introduce women education was missing in the government protocols, and if women are well educated, sanitation, women and men, and I would say, but here women, why? Because most of these regions are rural regions where the male is the farmer and the female takes care of the livelihoods in the house, including the children and the livestock. Okay, so women education was important. Dietary diversity was important. Healthier cooking stove options. So if you have a house where too much of smoke is evolved during cooking, that has an effect on the anemia. This was not on the government's website, so we added that feature. Okay, so child underweight is a very key feature, and caste vulnerability. So when you're doing a model, first check what is already available, and if your model is doing the same thing, then why do you need your model? Okay, try to identify some other features that maybe they didn't look out. This is what thinking outside the box is, right? So you think outside the box and find some other variables that could bring your COVID down. To conclude, the study tries to explore potential of machine learning and AI in the field of child anemia and social demographic factors. So child anemia connected with social demographic factors. Demographic is your male, female, and then social would be your education, sanitation, those kind of things. And there were some challenges also which we will come through. So model created for India did not work at district level, which is very, very key understanding. XG Boost was the best model of the models we used. Hypertuning was important to increase the parameters from 16 to 24. And machine learning can be used to find critical features which were not already executed in the programs. And so through these features and through these models, and when we went and gave the recommendations to the government, the policymakers could easily look into what kind of other features that they could concentrate. It's a very low hanging fruit, as I said. Okay. So one policymaker said, oh, okay, if I just give more dietary diversification, can I fight anemia? That is easier to do, right, compared to other measures, because they already have this midday meal program. So they introduced dietary, diversity in it. The second part was bringing the gas connections to the house. So when you brought the gas connections, your chulas and other things were replaced. So that brought a healthier cooking atmosphere and bringing the anemia down. So there's multiple things that the policymakers were very excited about this work. But this is where this slide, I would say, of all the slides is very, very important. This shows that you understand your model, you understand the data. Okay. And so if you give a model to a person, do not feel shy to tell about the limitations and ways forward. It shows that you know in depth about your model and in depth about how to take it up, or domain expertise. So what did we found? Other medical reasons for anemia are not pointed out in the study. For example, very deep medical reasons like bone marrow density, hemolytic anemia, etc. We couldn't get those data, and we did not tell, but we acknowledge that those have an impact on your anemic predictions. NFHS4 data has lots of missing values, which the study dealt by removing the rows. Just simply removing data is not correct. Okay, so if you have a data gap, if I say, okay, I'm going to remove the data, then you are removing a slice of data, like in terms of temporal time print. So that is very, very, not highly recommended. So you have to first try to fill the gap. If you cannot fill the gap, you remove the data. And that's what we did. So just removing the data is not correct, but we did not know how to fill the gap because it was a very socially demographic survey data. Selection of hyperparameters for the model was important, but we also should understand that that was purely a data-driven exercise, the hyperparameter testing. Okay, the initial parameters was good. That was domain knowledge. But then the hyper tuning was based on AI algorithms. So moving forward, models to require link with human domain experts, which is doctors, nurses, ground workers. In Anganwadis, you have these workers, Anganwadi people and teachers, etc. So those child caretakers should also be included in this anemic model. This was also a second case study which we currently published in the Oxford, publishing press. Another one was examining spatial propensity in child malnutrition across 640 districts. So again, if you look at it, this has nothing to do with my hydrological background, but because I know how to work with data and these AI and ML techniques, we used it to spatially look at data, and it was very good. Like in terms of, we could predict where the clustering of this disease was, and because of the clustering, we could understand what are the key features that are affecting that place. For example, if you're finding a clustering of like bone marrow density in Gujarat, then I could easily say, no, it could be fluorosis, where the drinking water just erodes your bone density. Okay. And then so those kind of things. So make sure you, when you cluster in a variables, if you cluster it spatially, you can also understand other factors, other proxy data that impacts your prediction. So the growth in India, as I said, it is. I'm very happy to see these youngsters like Deep and all taking this up forward, because at your age, I don't think I had this kind of opportunity. And the growth in India is very positive. Data collection is happening at very fast, very high speed, and big data is true in India. Why? Because almost everyone has smartphones. You could easily integrate them to bring data. Okay, so crowd science, citizen science, everything is possible. Data storage and retrieval is very cost effective now. So students, you can also get Amazon and the Microsoft Cloud, Google Cloud for free, right? When I started, using Gmail internets, we had 2 GB space. Now everyone has like a drive. Google Drive was not there then, like 5 years ago. Now everyone has Google Drive, and the Google Drive has space, a lot of space. So you can carry your data everywhere you want, and you can run your models through cloud. Internet of Things has tremendously grown, and it's still growing. It's very, very cost effective. Population, as I said, smart devices is high, and capacity for analysis is very big. So what you see right here is the biggest and most powerful supercomputer in India for an academic institution. The one bigger than this is at IMD, which they use for predicting weather patterns and stuff. We don't do weather patterns, but we do other analysis, high performance computing, etc. So this is the computer in IIT Bombay, and which has tied up with most of these labs in campus, and one of it is my lab. So yeah, so the opportunities exist. So you could use these also. So big data and AI can aid in better understanding health issues in India. That's what we found in our study. Data issues exist. Please be honest about it. Otherwise, your model is just another model. Most of these COVID models failed because they didn't understand the data. They said, oh, every day that if you just look at the data, every Sunday the data is less, or the number of incidences is less. Does that mean Sunday has a less preference of COVID? No, because Sunday people didn't go out. The number of testing was low. People didn't understand this. There was a cyclic pattern in your COVID positive results. And if I just take all the Sundays, for example, I didn't know this pattern, but I just took all the Sundays, then my model will fail miserably. So how do you bring that down is the question. Domain knowledge is key. A lot of people think that AI and ML can replace doctors, can replace humans. It is not there to replace it. Let's say we don't want to replace anyone. It is to coexist. AI can coexist with human intelligence, and domain expertise is the way forward. You cannot, remove one person on the other. It is not like self-driving vehicles. Self-driving vehicle is different. You don't need a domain. Yes, you still need a domain expert, but still, you can get away with. Most countries are doing self-driving vehicles, but in health, it is very, very costly to do a mistake. Application oriented research is key. So don't just do a model for papers. Don't just do a model to show on apps. Make sure it is applied on the field. If you can apply it on the field, then you can get better visibility and better accreditation to your work. The potential of growth is very high in India. And with this, I would like to thank everyone in the RUDRA team, especially Gaurav Dubey for doing that tremendous work, and and all those people who have invited me for this talk. Thank you.
Amazing. Awesome. Thank you so much, Professor. This was so insightful. What I can say right now is that I wish I was participating in the Gameathon and I could utilize the learnings from this and indeed the Gameathon and the project that I would build. But yeah, I really appreciate you taking time. We'll quickly go through questions. There's a tons of questions through YouTube. We'll try to cover as many as possible, but not sure due to lack of time. Anyone who's on Zoom, feel free to put your questions, and we'll try to get your questions answered through the
Sure,
professor.
Deep.
So,
Just to answer your part about the
sure.
infrastructure, those students who are interested in this supercomputer in campus, try to get an internship through IIT Bombay. IIT Bombay has a lot of internships. It is free, and sometimes you get paid for it. And once you get the internship, you can access the supercomputer through the professor from where you are. It's
Wow.
virtually across the globe. So I can sit in Chennai right now, access my supercomputer. So try to write to the professors with your ideas, and then they will, if they like you, the idea and stuff, the internship is possible. Yeah, go ahead.
Wow. Amazing. Just to add to this, is it possible that whoever is here who is watching this can apply through internship through you?
Yeah, so anyone can apply to me also, but again, I'm opening it to all professors in campus, not only to me. It's called the IRCC internships. Unfortunately, this time because of the COVID, we could not have them. Otherwise, every year we have every year we have around 200 participants from across India and across the world. So I had a student from US, and you're getting paid, and you'll be in campus for 2 months, I think. 2 months you'll be in campus, and you'll be paid. IRCC internships, just look at it. And there is a cyclic internship, which is every summer there is an internship, and there's also an internship for the last 6 months of your degree, like BTech or MTech. You have to do a project the last 6 months. That 6 months can be done in campus in IIT, if the professor accepts. If the professor accepts, they can write a letter to the dean, and then yeah, everything is set. So we have a lot of spaces and beautiful minds. And so I have to be honest, I have 7 papers with undergrads from other universities, not from IIT. And it's because of these internships. They come on board and they work very hard because they have only 2 months. So they work very hard, and then it get published in a good international journal. So I'm very happy for them. So it is very productive thing. So you can also apply. Yes.
Awesome. This is such a nice opportunity, not only career-wise, of course it is career-wise, but I have been to the campus and it's one of the beautiful campuses and the place is very serene, very quiet, peaceful, and the food is cheap and really, tasty over there too. So yeah, if it would be a great opportunity for anyone who wants to apply. Thanks for bringing this up. So, quickly going to a question from YouTube. Bias is a huge issue. How do you recommend someone who is starting off with analyzing data realize that there could be bias?
I'm sorry, it was too fast. What was it?
Sorry, I'll go again. So, someone on YouTube has asked that bias is a huge issue. How do you recommend someone who is starting off with analyzing data realize that there could be bias?
It was breaking a bit. Can you just put it on the chat
I'm
box?
sorry.
I got a
I'm
little
sorry.
bit of
Sure,
it.
I'll do that. I'll do that.
Yeah.
I'll do that.
So because there's some technical terms in the question, just put it on the chat box.
Yeah. So while I get this question put off, I'll try go again with another question is that does having
No.
multiple
I got the question. I'll just go through it.
got
Bias
it.
is
Okay.
an issue. Yeah. How do you recommend someone who's starting out with analyzing data? Yeah, so that's a good question. That's a very good question. So first, look at the how the data was collected. Okay, if the data collection instrument, etc., and run, there are some models to look at bias correction. So before bias correction, there are bias prediction models. Is it overfitting, underfitting, or is it just stationary data? Okay, so look at those terms, and then it's first a graph. It's just basically a graph, and then you'll get the equation, and then you'll see if the bias is there. The second thing is look at the instrumentation. If the instrument was used to collect temperature, you cannot take a water level with it. That's a bias, right? So how do you take it? So that's the instrumentation knowledge. So yeah, so first I would say is there are a couple of models just to look at understanding bias, and then you put it as bias correction.
Got it. One more interesting question, while this is also being put on Zoom, I'll try and say it, is thank you so much, Professor. Are there any sources where we find pre-built models in cases where it's a basic prediction that I'm looking for and don't want to reinvent the wheel on building the whole model again? So the question is that are there any sources where
Yeah, yeah.
anyone can find pre-built models?
Uh, to be honest, that's a beautiful question. Why? Because there's lots and lots of reinventing of wheel, wastage of time. So our model is open source. We put it on the paper along with the sorry, we put it on the web along with our paper. Which means when we publish the paper, we publish the model also in GitHub. So just go to GitHub. You can get lots and lots of these AI and ML models. People want you to use them so that you could also add to the credibility or the limitations of the model. Okay, so there are a lot of repositories. GitHub is the best I've known, and people just as freelancers, they just put their model along with the code, along with what are the issues, so that you could find and rectify it. Because some people can think outside the box, like my undergrads, they just think really crazy and different, and they could finish it in quick time. Or then what happens is you can add on to the model, like they'll do up to 5 level, you can push it to 10 level. Okay, so just go through it, and it's all about Google. Again, you have Google, just search for these models in GitHub. Type your question in the forum. There's a forum in GitHub. Just put your question like, I'm working on a model for COVID. Do you have any recommendations? People will be happy to respond. Don't go on Facebook and do it. That's not the place for it. Go to GitHub and those kind of things. Yeah.
One more question, could be an extension of the previous question, is that for India specific data, do you recommend data.gov.in as a reliable source? Are there any other sources like Kaggle that you recommend?
That's a good question. See, it depends where you want to use your model. If you want foreigners to use the model, use foreign data, I would say. But again, you want the government to use the data and your model. So use government data. All my models I use government data. Why? Because not because I'm a central government employee, but I want the government to use the data, use my model. Okay, so as long as you pick what is already accepted, then it's fine. So for example, you build your model with something else, and you want to take it to the ministry and say, please use this model. The first question they'll say is, I don't trust that data, I trust my government data, why should I use your model? Okay, so please, and honestly, we do good data. So government of India is doing tremendous work on collecting data. All countries have data issues. I worked in Singapore for the government, and even there I found data issues. So it's not like, a developed country doesn't have data issues. Everyone has data issues, but how you approach it is the key.
True, makes sense, makes a lot of sense. Okay, last question that I'm going to take from YouTube is just a moment. Uh, yeah. Does having multiple sources of data reduce bias in the AI models we generate? What are your thoughts on that?
Yes, beautiful point. Yes, because sometimes when you use different models with different data sets, or same model with different data sets, you can compare the performances, the indicators, uncertainty, bias, etc. And then you could zoom into, why is this model different with a particular data set? Why is the bias different? Then you can identify, is it an instrumentation error? So you can lock down on the bias correction. Okay, so yes, I do that often. I use different data sources, and then look into, if I could change the model, or is there need to change the data. So that's also a good question for picking a good data source.
Amazing. Okay. I think that is going to be all. I really, really appreciate it. I'm sure everyone else who's watching this does appreciate it too. Thanks a lot for taking time on this Sunday and talking with us, giving this insights from a lot of experiences that you have accumulated through the years that you have been working. So, yeah, we are really honored. Thank you so much for joining. And
Thanks a lot.
yeah, yeah, bye.
Thanks a
Have a
lot. You
good day,
guys are doing
everyone.
tremendous, and I'm hoping to see one of your outputs very soon. Bye bye.
Sure thing.